In this video, I will show you how to calculate various probabilities using a Venn diagram like this one. So we'll be calculating things like the probability of A or B, the probability of A and B, the probability of A given B, the probability of A and not B, all that kind of good stuff. So let's get started. 70 students were asked about sports they like to play. This Venn diagram shows the results of the survey. B equals plays basketball, T equals plays tennis, and F equals plays football. Use this to answer the following questions. Mini diagrams have been provided for you if you want to shade them, but it's not required. So, the first question is, how many students surveyed played basketball? Look, let me just mention real quick, there are two different kinds of questions here. Some of these questions are asking how many, and some of these questions are asking for probability. These are not the same. So please understand that whenever we talk about probability, we know that at its heart, probability is target over total. All right, it's whatever you are trying to find the probability of, that's the target, divided by the total amount. So if I see probability, I'm going to have a fraction or a decimal or a percent. If it just says how many, this is just going to be a single number, not a fraction, not a percent. It's just going to be a number. Okay, and in this case, it's going to be a whole number because these are all whole numbers. So, how many students play basketball? So, be careful. A common mistake is to say 15 because that's the number of kids that just only play basketball and no other sports. But you must understand that this entire circle represents students who play basketball. All right, this is the basketball circle. So that means that all of these numbers represent students who play basketball, all of them, even the ones that are also in other circles, meaning that they play other sports too, but they must be counted if I say how many students play basketball. So let's see, 8 and 2, that's 10, plus 15 would be 25, plus 6 would be 31. So 31 students play basketball. Okay, maybe I'll just shade these little pictures for fun. Okay, what's next? Problem number 10. How many students play neither basketball nor football? Okay, so if I'm going to start shading in, I really want to use the numbers though. Neither basketball nor football. So, in your mind, think of a number that represents students that play neither basketball nor football, like one of the numbers on the screen. Okay, well look, this is the basketball circle, so we got to stay out of that. This is the football circle, so we got to stay out of that. All right, here's a number. All right, this is outside of the basketball circle. It is also outside of the football circle. So these 8 students play neither basketball nor football. Here's another number that is outside of both of these circles. So both of these numbers represent students that play neither basketball nor football. So if we add these together, that's going to be 27. So 27 students play neither basketball nor football. Okay, let me erase that before we go on to the next problem. Okay, number 11. Now we're doing probability, target over total, so watch out. what is the probability that a student plays none of these sports? Well, we're doing target over total. So let's see, what's the total? Do they tell us? 70 students, so that's definitely going to be the total. All right, the target is students who play none of these sports. So which number represents students that play none of these sports? The 19, all right, it's outside of all the circles. So 19 students play none of these sports. So that's why it's going to be 19 over 70. And I'll just copy it down here, 19 over 70. Okay, let me erase that. And now the next problem. Problem number 12. A student is randomly selected. What is the probability that a student plays basketball given that he or she plays tennis? Okay, this is a given question. That makes me want to write this down. They're asking us for the probability that the student plays basketball given that he or she plays tennis. All right, that's the notation, by the way. And like we did before, we're going to do target over total. Here's the reason why I love given problems, because they practically give you the answer. I'm always talking about target over total whenever I'm doing probability. Well, guess what? The given, all right, this is the probability of B given T. The given is always going to be the new total. All right, the original total was 70. But when you have a given problem, you have a new total, a smaller total, and here it is. In this case, it's going to be T. The other number, guess what? That's going to be the target. So what you want to do whenever you have a given problem is start with the new total and highlight that. So the new total is T. This is the new total. Highlight that. And cross out everything else. This is the new total. So if this is the total now, that means nothing else exists. So it's very important to cross out the 15 and the 6 and the 11 and the 19. That way you won't be tempted to use those numbers later. So this is going to be the new total. And so what is that? That's, let's see, 10, 8 and 2 is 10. And then 8 and 1 is 9. So this is going to be 19. So the new total is 19. So that's going to go in the denominator. Now how about the target? The target is B, but be careful. We're not going to use any of these B's that we canceled out. So the target is just the B's that are inside the new total. So can you see that 8 is a B and 2 is a B? So this is the target. So that's why the target is 10. So that's why the numerator is going to be 10. So that's why the answer is 10 out of 19. So problem number 13 says we need to find the size of F and T. Notice it says size, not probability. So we will not be doing target over total. We'll just be finding a number. So please remember that F and T, one way to think of it is that's just going to be the overlap. Whoops, that's not it. It's going to be the overlap between F and T. All right, so here's circle F, here's circle T. This is the part that's sort of in the middle between F and T. So if I look at the large picture, okay, this is the overlap between circle F and circle T. So that is 3. And that's just the answer, not 3 out of 70, just 3. Okay, there's something else that I sometimes like to do, just another way of thinking about it. If I have and, I start with, if I have A and B, I start with A, and then I make it less using B. If I have A or B, I start with A and I make it more using B. So and is less, or is more. So if I look at it that way, F and T. So I could look at it as, all right, I'm going to start with F. So if I start with F, that's going to be this and this and this and this. All right, that's F. But and is less. So I'm going to make this less by using T. So when I say using T, it means it has to be T. T has to be true. I need numbers that are in T. So that means I have to get rid of the 6 and the 11 because they're not in T. So that leaves me with the 2 and the 1. All right, so I could look at it as starting with F, and then I make it less because of T. It has to be T. All right, and I could, I'm going to use that same technology, that same theory. If I have F or B, I'm going to start with F, and then I'm going to make it more using B. So I'm going to start with F, though. Oh, I thought that was the eraser. So, okay. So I'm starting with F. So here's F again. But or is more. So I have F, but now I need to make it more by using B. So I'm going to take this, and I'm going to add to it anything that's in B. So that would be the 8 and the 15. So this is going to be the total of F or B. Now this one is probability. See the P? So I do need to do target over total. So this is going to be a fraction. We know that the total is 70. So I'm going to go ahead and put that down. Okay, and now this highlight is the target. So I just need to add all these up. Okay, so that's just going to be 15 plus 8 plus 6 plus 2 plus 1 plus 11. So that's 43. So that's why the probability is 43 over 70. Okay, what's next? All right, this says the probability of T given F. So this is target over total. This is a probability. I mentioned before that the reason why I love the given problems is that the given always turns out to be the new total. And the other number always turns out to be the target. So F is the new total. Let's start with that. All right, F is the new total. So I'm going to start by highlighting F. All right, when you have a given problem, start by highlighting the new total. So because this is the new total, this represents everything now. Nothing but this exists. So we have to remember to cross out all of these other numbers because this is the new total. That means there can't be any other numbers. So this tells us the denominator. So this is 11, 17, 18, 20. All right, so the new total is 20. All right, now we can move on to the target, all right, which is T. So I look back at the picture. Now, I carefully crossed out all these numbers so I wouldn't be tempted to pick any numbers that are crossed out. So I'm not going to pick these. So the only remaining numbers that are in T are the 2 and the 1. So this is the target because it's in T. So that's 3. All right, so that's why the answer is 3/20. All right, at number 16, they want to know, are events T and F mutually exclusive? Remember, T stands for playing tennis, and F stands for playing football. So are those mutually exclusive? Mutually exclusive means there is no overlap between the sets. For example, if one set is being a freshman and one set is being a junior, there's no overlap between those two sets. You can't be a freshman in high school and also a junior in high school at the same time. So those sets are mutually exclusive. So these sets obviously are not mutually exclusive. You can see that F and T are overlapping. I mean, here's set T right here, and then here's set F right here, and you can see that those are overlapping. And just using your common sense, you can like tennis and football at the same time. So that's why these are not mutually exclusive. And there you go. A person can like both tennis and football. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.